Hello class, today we're going to learn about how to calculate the area of certain shapes and how to calculate the volume of some other shapes. We're going to learn how to calculate the area of squares, rectangles, triangles, and parallelograms, and when we're finished with that we're going to learn how to calculate the volume of basic blocks. Now area is the count of how many little squares will fit into a given area. So if you imagine a square that's 1 inch by 1 inch, and you cut that out of a piece of paper, you're going to say how many of those squares will fit into the shape that you're analyzing. So we'll learn that when we discuss area, we consider square inches or square feet. The unit is usually squared when you discuss area. There are, however, some specialized units that are always area, such as acres or hectares. So here we see the area. 1 square inch is 1 inch tall and 1 inch wide. That is what represents 1 square inch. So the rectangle and formula for a square and a rectangle, figuring out the area, is multiplying the length times the width. So if we go back to this simple 1 square inch, it's 1 inch wide and 1 inch tall. That means that it's 1 square inch. 1 times 1. If you'll see length times width in this next example, 1 times 1 would equal 1. So in that simple instance, it's 1 square inch. Now, when we get a little bit more complicated, we can consider triangles. In triangles, you always want to measure the base times the height and then divide by 2. And there will be some examples at the end of this discussion, and we'll practice some of these all together. Then the next type of area we want to consider is the parallelogram, which is base times height. Much like length times width, but you'll notice a parallelogram is usually squished one way or the other. So you don't use the side to measure it. You use the line from the bottom line to the top line, and we'll see that in some examples as well. The next thing we want to learn about is volume. So volume is just like area, only it takes into consideration the third dimension. So it's the amount of space inside of a solid figure, like a cube, ball, cylinder, or pyramid. The units of volume are always cubic. That is the number of little cubes that fit inside the figure. So if you think about building blocks that are square, those would be like the example that would fit in the figure. So here we see a cubic inch is 1 inch by 1 inch by 1 inch. So we'd go 1 times 1 times 1. So this cube here is equal to 1 cubic inch. The only rectangular that we are going to discuss, and it's called a rectangular parallelepiped, which just means it's got rectangulars on all of its sides, either squares or rectangles. And for that, to calculate volume, it's length times width times height. So, we discussed area for two-dimensional objects. We come out with unit squared. And we discussed volume, which are three-dimensional objects, and that is cubic units. Some references that we have are www.math10.com and home.avvanta.com. Those are both some places to get some additional information about math, and again, area and volume if necessary. But before we go, let's work on a couple exercises. So, let's work through some exercises together on calculating the area of certain shapes. First, let's look at this rectangle. It's 4 inches by 3 inches. Now let's put on our thinking caps. Look at the top there. Remember, the formula is length times width. And don't forget, we want to make sure to be labeling our answers. So, take your time and think about what you would write in this answer. I'll give you a couple seconds. The answer I came up with is 12 square inches, or 12 inches squared, depending on the way you like to discuss things. So that's 4 times 3 gives us 12, and then because it's area, the units are inches squared. Now the next piece of image we're going to look at is 10 feet by 10 feet. Can anyone help? Take your time, write down in your workbook here what 10 feet by 10 feet is going to give you an area. I come out with 100 square feet. I would hope that you came out with the same. Alright, now we've got triangles. There's two different kinds of triangles that we're really thinking about here. There's right triangles and there's triangles that are not so right. Anyway, we've got a triangle that's 3 inches tall and 4 inches wide. So look at our formula. The base is 4 inches. The height is 3 inches, and then we divide by 2. So in this situation, we'd have 4 inches by 3 inches, which is 12, divided by 2, which should give us, fill in your answer quickly, and let's see what we come up with. I came up with 6 square inches, and I think you'll come up with the same. Next, let's look at this next triangle. It's a little bit different, but this formula still works. Now we're considering base times height. So we took a look at the line segment at the bottom, and then the line segment that goes parallel from that base segment to the point of the triangle, and that is your height. So if we take 5 times 3, we get 15. Divide by 2. Everybody, what's your answer going to be? I came up with 7.5 inches squared. You're okay writing 7.5 or 7.5. Now, a little bit more complicated, we've got some parallelograms. They're just like rectangles, but they're kind of like triangles in that here we have actually a rectangle, or a square, or a rectangle with 2 triangles, 1 triangle on each end. Well, over time we've learned the simplified formula is base times height. So we see the line segment at the bottom that's 10 inches long is our base, and the line segment that goes from that base perpendicular to the other side is the height. So here we have a parallelogram that's 10 inches by 5 inches. So what are we going to use for the area for that? 10 times 5, right? Base times height. What do you come out with? I come out with 50 square inches. Next one, this one's just tipped a little sideways is the only difference. Let's think about that one. We've got 15 inches for a height, or for a base, I'm sorry, and 3 inches for a height. That's 45, I think. There we go, 45 square inches. Now, volume. Volume, we went length times width times height, and the answer is in cubic units. So here we have 10 times 15 times 20. I almost had to get my calculator out, but I was able to come up with 150 times 2 is 300. Add a 0. I believe that the answer is, write your answer down quick. I came out with 3,000 cubic inches. And then the next one is actually kind of a little bit more simple. 10 by 10 by 2. So that's 100 times 2. What do you come up with there? I would come up with 200 square inches as well. There we go. And that's the examples that we have. We'll have a couple of quizzes for you to work through. And I want you to finish your workbook before coming to class. We have some exciting things that we'll be doing in class with this information that we've learned. So I look forward to seeing you in class, and have a great weekend.